This presentation will discuss building gate access control applications, specifically human temperature monitoring solutions using the thermal IR sensor. Since the spread of COVID-19, human temperature monitoring applications have become increasingly popular worldwide. The D6T thermal IR sensor is able to support these sorts of applications, such as on an access gate or an entryway. The sensor offers three key features which make it ideal for this sort of application. First, the sensor is touchless, so it is able to collect accurate data without risking the spread of harmful bacteria. Its I2C digital output makes it easy for the customer to collect and utilize this data for their application. And lastly, this sensor is a PCB module type, so the sensor itself includes a chipset which has software to convert readings to temperature. This way, the customer does not need to develop their own calculations, and the sensor is ready to use upon installation. This slide shows our Omron thermal IR sensor portfolio. As you can see, Omron has a broad product portfolio for the thermal IR sensor. For the applications with gate access controls, the matrix type, or the 4x4 type, is recommended. You can see it highlighted in orange on this table. Here we will discuss why Omron is recommending the 4x4 matrix type for this sort of application. For our thermal IR sensors, the output is the average temperature in each pixel. For gate access applications, typically the required distance is around 50 centimeters from the human to the sensor itself. Therefore, the matrix type makes it easy to separate the human temperature from the background temperature. In the display below, we have the matrix type versus the single pixel type. In the matrix type, we have 2 cells out of the 16 that have the entire human body temperature that can be read. Therefore, the other cells can be ignored. However, in the single pixel type, the output would be the average temperature of not only the human face, but the background objects as well. So the customer, in this case, would not be able to get a clear reading of the temperature of the human body. In the next few slides, we will go over different calibration tips that the customer may use to improve the sensor accuracy. By default, Omron thermal IR sensors guarantee an absolute temperature accuracy of 1.5 degrees Celsius. If a higher accuracy is needed within a certain range, customer calibration is recommended. The 2-point calibration method is a better way to improve the accuracy. First, one must set a blackbody object temperature to the lower and upper limits of the operating temperature range. For each sensor, read the sensor output at the points Y0 and Y1. It is recommended to start reading data 15 minutes after turning on the sensor, and the average should be based on measurement data from at least 10 points. The sensor output value is corrected by incorporating a calculation formula for the correction into the master MCU. If the sensor output value is X and the corrected object temperature is Y, the formula is shown below. As a result, accuracy can improve to 0.2 degrees Celsius by a 2-point calibration. Here we have the 1-point calibration method that the customer may also use. The 1-point calibration method is a faster way to improve accuracy, but with limited improvement. The method is similar. Set the blackbody object temperature to the center of your operating temperature range, or X0. Read the output data for each sensor and calculate the difference from X0. The sensor output value is corrected by incorporating a calculation formula for the correction into the master MCU. If the sensor output value is Pn and the corrected object temperature is Y, the formula is shown below. The error increases as you move away from this corrected point. For example, X0 is plus or minus 2 degrees Celsius. The maximum error is about plus or minus 0.3 degrees Celsius. Because of the limited improvement that you will get from the 1-point calibration, it is recommended to use the 2-point calibration for better results. This slide will discuss how to read the black body temperature using the Omron D6T sensor. The sensor can be calibrated through the application or on its own to improve the accuracy. In the methods discussed before, these are ways to improve the temperature accuracy using the sensor alone and a black body. The below slide shows a detailed way of calibration using these methods. There are 2 key points to remember. 1, the distance required between the D6T and the black body will depend on the field of view of the sensor. Second, it is recommended not to hold the sensor in your hand when measuring, as the sensor can be affected by your temperature. Be sure to attach the sensor to a fixed jig or an enclosure and measure it from this point. If further information is needed, please see the contact list below to reach various Omron specialists around the world who can help you with any further inquiries you may have on the D6T product. We also have data sheets available in multiple languages, and in addition to the thermal IR sensor, Omron has facial image sensing technology for gate access control.